Hi everybody. Thanks for coming today. Hopefully we've got a good session planned for you. I hope everyone saw the keynotes this morning, both Satya's and Jason's, where we announced Azure Synapse Analytics. We're going to dive into that a little bit more today. But what I hope you heard as well from those sessions is that Synapse is really the evolution of Azure SQL Data Warehouse. If you're running Azure SQL Data Warehouse today, you are on the right path to automatically become a user of Azure Synapse in the future. And if you're wondering what you should do right now, SQL Data Warehouse, or Azure Synapse as it has become today, that platform really takes you to all of the capabilities that we're going to be showing you in all of the sessions this week. What I want to do today is talk around migrating. There's a lot of movement in the space right now about migrating legacy appliance platforms onto the cloud. We've engaged with hundreds of customers worldwide to do this with what's been SQL Data Warehouse to date. All of those projects continue, and you should think of Azure Synapse as being your cloud-based home for these enterprise legacy appliance warehouses that you've run in your data centers. So I'm going to take a run at this from two levels. Really, I want to sort of touch on a high level about what to consider when you're migrating, but I also want to dive directly into the code as well. I'm going to run a lot of code demos directly out of SQL Management Studio. First of all, it's to reflect the fact that Azure Synapse is not at all a closed ecosystem that you can't work with. All of our existing applications like Visual Studio, Management Studio, Azure Data Studio, everything just works. We'll talk a little bit about our partner ecosystems for data integration, data visualization. Everything just works. In fact, we've tested them with Azure Synapse, so we can stand behind that functionality. So there is no regression, there is no breakages in our own capabilities that were outside of the Synapse service, nor in our partner ecosystem. So I'm going to talk a little bit around, just touch on the migrations, the benefits of migrating to the cloud. I think the cloud has certainly, as you saw and Rohan touched on this morning, Azure Synapse has executed all 22 queries from TPCH at petabyte scale. To our knowledge, no one has actually achieved this feat. And so if there are any question marks over whether the cloud can scale to your workload, the answer today is probably yes. In that petabyte workload, the largest table has 6 trillion records. And there are queries that join it on itself 2 and I think possibly 3 times. So these are very expensive, massively computational heavy queries. And the scalability of Synapse is what enables us to run this long-standing industry workload at the petabyte scale. I think the largest actually published today is about 30 terabytes, just to give an example of the scale that we've achieved. I'll talk a little bit about some of the leadership that the platform has and pulls through from Data Warehouse, and I think of them really as platform qualifiers. We'll look at some of the components that you need to migrate, and then finally, Ann Cruz, who's with me here from Walgreens, will come up and talk about their journey for migrating from the Netezza platform onto SQL Data Warehouse, and now they're onto Synapse, I should say. Got to keep working on that. It's a bit new, you know, and she'll tell a little bit about that at the end. So let's get started here. I just want to reiterate this message that this is not a net new thing that you need to go learn. This is the evolution of Azure SQL Data Warehouse. At 8:55 this morning, I was a GPM on the Azure SQL Data Warehouse team. At 9:01, I became a GPM on the Azure Synapse team. So I had to make some slight adjustments, but aside from that, I really want to emphasize the continuity of the experience in the platform. And you may have seen this slide if you were in Santosh's session earlier, but what this really does is provide sort of a lower level technical example of what is in the Synapse service. And so you can see here, we bring together these common platform capabilities of management, security, monitoring, and Metastore. We bring data integration directly into the single service. We bring both our industry-leading SQL runtime that you'll be familiar with if you run SQL Server, SQL Data Warehouse previously, and we bring Spark into the platform as well. We bring different form factors that you can run reserved capacity that gives reserved multi-level caching so that you get that blazing fast performance and predictable query execution. And we also bring the on-demand where you pay per the amount of data scanned, and each of those play off each other for the different scenarios for your analytical requirements. And then because we're pulling these runtimes through, we pull through all of these languages as well. So in the same integrated analytics studio, Synapse Analytics Studio that you may have seen at the booth and if you're in Santosh's session, you can now just flip between different languages and map them to the runtime, and it all just works. And that level of integration we think is unique in the market today. What I also want to touch on here is the connected services. So like I said, this is not a closed ecosystem, neither to Azure services, traditional client applications that run on your PC, or even our ecosystem of partners. And so if data integration like Informatica, Talend, Attunity, we've had a new partner launch called Panoply, who's just made their announcements here at Ignite this week. They all just work, right? Whether you're on the visualization side, like MicroStrategy or something like Click, all of that just works. If you still run reporting services, obviously that still works. And so it's a very streamlined story in what we think of connected services working with Azure Synapse. So if I start to sort of drill into some of these benefits, like why migrate? Why am I going to the cloud? I've got this giant appliance, it's been working great. When you start to peel back and you consider some of the other benefits of moving to the cloud, things start to get a little more obvious. So the first thing is the elasticity of the cloud gives you tremendous economics, not just for being in the cloud, which you can get, but for analytical workloads in general. When you look at the profile of resource utilization for analytical workloads, they are very, very spiky. And unfortunately, you'll see periods of time where you're running at absolutely 100% capacity and you've got nowhere to run. And then you'll see other periods where you've got nothing or close enough to nothing running. And the actual aggregate utilization of that warehouse appliance could be anywhere between 20 to 60% on the aggregate. And so the elasticity of Synapse and the ability to effectively scale this compute, it was mentioned this morning how we separate compute and storage. We bring multi-cluster form factors to it, so one cluster can run, another one can go away. The elasticity of each of those independent clusters, that yields tremendous economic benefits, and the same applies to the Spark capabilities as well. Because we're bringing multiple runtimes into the platform, we're no longer asking you to jam the wrong analytics scenario into a relational platform. I built data warehouses for a long time. Once upon a time in the Microsoft ecosystem, the answer was always integration services, SQL Server analysis services, and reporting services, right? And then I'll take your questions, please, or your requirements. But the reality is that I talked to a lot of companies who are starting to do image recognition. They started image analysis, pattern detection. They're trying to do audio. You know, a lot of these yield data that goes into the tabular formats of relational platforms. But the engine to actually run that first phase analytics is not going to be a SQL language in tables and columns. And so the fact that now we can give you these data lake architectures where you can bring any data into the platform and bring the right engine with the right language, with the right set of libraries to do the right type of analysis, that's incredibly powerful for emerging analytical scenarios. And this then leads, obviously, into the third benefit of analyzing all of your data, right? Before we had data lake architectures, and I think they sort of grew out of HDFS in on-premise Hadoop clusters, you had Windows file shares. I built a lot of data lakes on Windows file shares many, many years ago. Now we can store all data and keep all data, and you can analyze all data as it was born and as it arrives into the platform. Hybrid really talks about how we can ingest data from various places. You will have applications that exhaust data that run in Azure. The data will be born in Azure. And you will have applications that run in other clouds as well. And you will have your own data centers. And you will have SaaS-based applications as well, where you just have an API to connect. There's no database at all, right? And so, Dynamics 365 perhaps is a great example of that. And so what we've done with the integration capabilities is offer over 90 out-of-the-box connectors that lets you connect seamlessly to all of these sources, other clouds, cloud-borne applications, and securely into your own data centers, and bring that data into the Azure Synapse platform to start to join together and find those interesting insights. This leads us to breaking down these data silos. You'll see in the Azure Synapse Studio that all of your data is available in one place. If I'm doing analytics type A, I don't have to copy it from B to C to D for different analytics. I get out of synchronization. I spend 80% of my time just building pipelines to have data go back and forth between systems. By bringing all of the data into one place and then bringing the compute to the data without needing to stitch and VNet and do all of these complex things with multiple cloud services, this is going to simplify and dramatically accelerate your time to solution. And finally, governed self-service. Self-service, I think analytics was really born about a decade ago through the likes of Power Pivot, for those who remember, in Excel. And really, we see a lot of customers wanting to empower all of their people with self-service analytics. The problem here becomes that when you start to move away from monolithic BI tools, where you had one tool and a team of analysts who were building reports and then serving them out to the business, what we noticed was happening was that a lot of security was being split between the application layer and the database layer. And when you go to self-service BI and you actually encourage customers or your users to actually use other applications, you can't maintain application-level security when you've got 6 different BI applications. And and people may write their own applications. And so what we've done here is, and I'll show a demo of this shortly, is we've bring the most fine-grained security directly into Azure Synapse. So now that you can secure data for SQL queries down to a single cell in a table, regardless of the size of the table or the volume of data that you're managing. The challenge, so you look at this and you go, this is great. I'm going to cloud, I'm going to go to Azure Synapse. What are the challenges? Migrations are hard projects. First of all, they take time. And at the end of it, you've gone from point A to point B, you've lit up some more capabilities, but because they take time, they also cost money. And so when you start to get into these scenarios where you've got these long-running projects, as sometimes happens, these start to get relatively risky. And so what we're looking at Microsoft now, and I'll talk about some capabilities we'll ship next year, is how we can help you fully automate the migration of a lot of this code. For the last year, actually, we've built tooling, and we've worked with, I'd say, easily over 100 customers worldwide to fully automate the code migration from their legacy platforms into Azure SQL Data Warehouse, and then future into Azure Synapse. This is a tool that we ran internally. The reason for it's really simple. If you sit down one Sunday and say, I'm going to build a tool to convert all of Teradata to SQL, you're going to be there for a little while. So what we actually did is we worked with customers and figured out what people were actually using and built those capabilities in. And next year, we're going to ship this and make this available as a download for everybody to automate your code conversion. I'll give you a really quick demo of that tool today during the session. So let's talk about qualifying platforms, right? The first thing you need to know about appliances is they're screaming fast. I can tell you 10 things that are wrong with them, but the most right thing with them is they're screaming fast. And so as you saw today in Rohan's session, SQL Data Warehouse or Azure Synapse is the industry leader for price performance relative to other cloud warehouses. And that cutoff at the top is the 94% or 18x that Rohan talked about before. If you're coming from an enterprise data warehouse appliance, hardware optimized, built and designed for speed to run analytical workloads, you're not going to find a more cost-effective place to go run that workload than Azure Synapse. What's interesting about these two benchmarks is the top one is TPC-H. It's a 30 terabyte scale, and this was run in January of this year. And then TPC-DS, which is comprised of 103 queries, was run in March this year. And so these benchmarks, we've not seen anything published since. These have stood the test of time, at least in cloud world. Staying the test of time for 8 months is actually doing pretty well. But what it actually shows is that I don't think anyone, or certainly not my recollection, has ever been able to stand up and claim both of these benchmarks that are so distinctly different. And so we truly believe in the price performance characteristics of the platform, and we do have reserve capacity that if you take a 1 or 3 year commit would push those green bars down even further relative to our competitors. With respect to security, we think about this as a strategy of defense in depth. When you're asking us to run your enterprise data warehouse, you will be giving us some of your most sensitive data, and you want to make sure that that is secured in Azure. And so we think of this as 5 distinct levels, everything from proactive threat detection and vulnerability assessments, auditing on user activity on the platform. But the ones that I'd really like to drill into is around access control. What we've enabled in Azure Synapse is native row-level security on the SQL data, native column-level security, and dynamic data masking as well. And so I'll give you a quick demo to show you what these look like. If I just switch over here, and I can make this a little real. So what you'll see here is I'm going to run some demos in Management Studio. And the reason I'm going to run these demos in Management Studio is not because I couldn't run them in Azure Synapse Studio, but the one thing Azure Synapse Studio doesn't have at the moment is side-by-side code. And for before and after, it's kind of useful to see these things at once. So let me go zoom here as well, because I know that's probably going to be helpful. So on the left here, I want you to look at a couple of things. I'm logged in here as SQL DWA. This is an administrative user. They have full access to the platform. But these two sides, I am running exactly the same queries, top to bottom. The only difference here is that I'm connected to as CA here. Different user, same server, same everything. And so I'm going to go run this query and take a look at it. We're just doing something basic from a table, give me a filter, group by sales state. And so US states are sort of, that's a nice distinct set of them. There's only succinct set, there's only 50 of them. But I've got row level security here because I've got a set of analysts in California and they should only see Californian data. And so if they go and run exactly the same query here, they're going to get 1 row. They don't know what they don't know. And because it's in SQL, you can walk up to that with any application. They need to log in as themselves because everyone should only have 1 login. And the platform will apply the fine-grained security for you. This is the only cloud data warehouse that offers this capability today. The hack for this traditionally has been creating views, put a filter on the view, secure the view, 50 US states, 50 views, go modify the schema, go modify 50 views. You got all these analysts who see all these views they don't need. It just creates an absolute mess. So we can put it directly on the table, and users just need to run the same query regardless of who they are. But I mentioned that we do column level security as well. So now let's go and take a look and pretend that I'm looking at these columns. Fine, I get a set of columns back. But now I've actually gone and secured date and month against this user. And so if I go run this, actually, I'm going to get an error. And so what I could actually do now is imagine I could filter using row-level security down to a single record in a table, and I could actually block access, select permissions to all the other columns. So I can only query one column, and that would only return one row. Single cell level security in the table directly at the SQL layer. But I want to show you one more thing as well, because sometimes you don't want them to see the values, but you need to maintain the schema so you can fulfill the report properly. And so what we also offer is dynamic data masking. And so here I'm going to run a query again as the admin. Oh, actually, before I do that, I just had another query to show you. Taking those two columns out, if we don't hit them, works as you would expect. So now I've run this query. And again, I've got full access, so I can see everything, no problem. But now, actually, what I've done here is I've got to mask Saleszip because I need them. I've got a report, and it's got a fixed table that it's expecting columns to come back in the report. And so now I'm going to go run this. And fortunately for my report, the results come back, but we just masked them. And those 4X's is a custom pattern that I've assigned. We also have built-in system functions as well, such as email, that will identify that it's an email address and turn it into xxx@xxx.net. And so that at and .net, the structure of it is obvious that it's an email. So that's kind of useful if you're expecting that in the field, but we don't let you see the value. But the critical thing about this is all built directly into SQL. And so it doesn't matter. This is the governed self-service BI. And this is some of the very distinctive and differentiated security features to think about when you're moving these very, very sensitive workloads off these warehouses and moving them into the warehouse, into Azure Synapse. Let me flick back to the slides here quickly. So now I'll start to break down the three fundamental. Migrations are hard. I'm not going to be the guy that says, hey, you just have to do data integration and warehouse reporting and you're migrated, right? We have a finite amount of time here, and I need to try and up-level the message to hit every point. But what we've done with data integration is we have enabled the 90-plus connectors that I mentioned directly in the Azure Synapse Studio. So when you log into Synapse now, you can click on the Orchestrate hub. In there, you can set up and start to build these graphical pipelines. And what we've also done is built this completely code-free experience. And so when you're building data integration pipelines, you can look at actually whether I'm a developer, I love writing code, I write SQL, so I think I can solve any problem with SQL, not so sharp with Python. Or I can actually build these, which is just a complete drag and drop, and under the covers, they will generate the code and deploy that for transformation at scale onto fully managed clusters. One of the great bottlenecks with implementing enterprise data warehouses was where ETL technologies flowed through a single box. One of our partners actually who solved that quite nicely is Informatica, where they did an optimized pushdown into the distributed SQL system. Informatica have actually also enabled that for Azure Synapse as well. And so if you're depending on that pushdown with Informatica onto Azure Synapse, you'll find that you can bring those Informatica components onto Synapse and leverage the exact same SQL pushdown that you've benefited from Teradata previously. I mentioned earlier that Azure Synapse is absolutely not a walled garden, and this segues in quite nicely. And so what we've really done here is enabled what we think of Azure Synapse in the middle and then these connected services. Power BI, for example, we give you the developer experience directly in the studio, but you're connecting to the Power BI service and you're publishing to powerbi.com. Azure Machine Learning, as you saw in John's session in Jason's keynote this morning, gives you that Azure Machine Learning, that code-free ML experience directly in the studio. But it's still something that we're integrating with as well. And so when you think about the ecosystem here, for integration, some of our common partners Talent Informatica, Attunity, and Panoply, who I mentioned, just launched this week. These are all fantastic capabilities. And if there are scenarios where you're running some of these existing platforms, you want to continue to run them, they've got some nice features that you'd like to bring in, you can be confident these are all going to work very nicely with Azure Synapse. One of the things, and I'll just give it a case reference here, that we recently worked with Informatica on is with Kelly Services. And Kelly Services are really matching talent to companies and helping with that hiring process. And one of the big achievements here was this ability to really massively improve the accuracy of results. This combination of Informatica and SQL Data Warehouse has provided this very scalable analytics service. And hopefully Kelly saw the announcements this morning that they're now an Azure Synapse customer as well. Let me now get into the data warehouse section and talk a little bit more about this. So one of the tricky things about migration is if you need to stop and remodel and re-architect. And so there are 5 fundamental features of how we store data in Azure Synapse that are critical for de-risking these migrations. And if you think about that time, cost, risk, you can sort of work backwards and say, okay, less risk, probably less time and less cost if I don't need to re-architect and remodel this. And so these 5 things, columnar storage is just table stakes. It's the default default table format when you create a table. And at Ignite, we've announced the GA of explicitly ordered column store as well. Some other platforms, I think, call this like cluster by or order by or something. But it creates a holistic ordering of an entire table so that where you have where clauses on that column, you're going to prune away row groups and columns and partitions incredibly efficiently. We also have table partitioning, so ranges where you can set up, say, month is the classic one for large tables, and I have a transaction date and I want to partition that on month. And then hash distribution as well is how commonly these platforms have been tailored and optimized over time. And then we also, and this is unique in cloud data warehouses, have non-clustered secondary indexes that can order other columns of the table. And so these structures combined are unique in the cloud, and they enable you to effectively pick up a data model from a legacy appliance that has supported all of these features and just drop it onto data warehouse because we have the parity of support for these capabilities. So one example, and I'll just sort of walk through a little bit of code here. This is what a very basic create table statement looks like in Azure Synapse. And so clustered column store is actually default, but I just put it in here to be verbose. And then I mentioned we've just GA'd ordering of that column store as well. What you'll see here is something brand new that we haven't shipped today, but we're going to ship. I'm giving you a peek into the future. We're introducing multi-column hashing distributions. This was the big headache, I'd say, for customers who were migrating, because if you've been building those Teradata's and Netezzas for a long time, it's highly likely that you've got multi-column hashing distributions. So we're going to release this probably early in 2020, so don't go out there and try and run this now. But as a look into the future, this was the one gap where customers were bringing us that DDL from these appliances, and we had everything covered. However, we were asking them to choose a single distribution key. And often they couldn't because there was a really good reason that they didn't just use one on Teradata in the first place. And so we're going to support up to 8 of these. It's generally the bulk that we've seen. But we've started to work with some customers really early on this feature, and it's proven to be a massive time saver because they just don't need to think about remodeling appliances that sometimes have tens of thousands of tables. It's not a small problem at all. And then finally at the bottom, partitioning as well. And this is what partitioning looks like in Azure Synapse. And so you just create this up front. You can obviously split ranges, merge ranges, and all of that stuff, switch partitions, all of that classic behavior that you're familiar with and you need in your implementation, but you declare it directly in the table DDL. So let me flip over to another demo now, and I'll show you a little bit of what this looks like. We'll go off this one. We'll do our code side by side again. And so here I'm going to go and create, I think I need to drop this guy. So we'll go and drop, and here I can just create a basic table. So this one's no problem. Single column partition, no problem. This is the multi-column demo that I want to give you. But what if I want multi-column? So let's go drop this again. It's not there. It's good. This is the error message you received today when you try to do multi-column. In fact, if you go home and try this yourselves, I've done a little get ahead for you because this is what you're going to encounter. So let me switch over to a future build that we'll release next year. So we'll go drop this guy, and I can create, obviously, my single column. We're not going to deprecate that. That's still really important. But now I'm coming from something like Teradata, and I've got columnar, and I've got it ordered, and I want to distribute on multiple columns. And like I said, we'll support up to 8. And then also the partitioning. And so let me go run this guy. And now this works. And so this will become available to you early next year. It's not there right now. I want to make sure I set expectations very clearly on this one. But as we've worked with a lot of these customers for a long time now, this is the big one that they've asked for. We've been working on it for a little while. There's actually a bit of work there's multiple levels that we need to touch on to make this capability work. But this is going to come in early 2020. Let me switch back again to the slides. The button is a long way under the desk, so challenge. Now let's talk about views. So when you're migrating views, you've got 2 different types of views in Azure Synapse today. You've got views, and then you've got materialized views. Materialized views are commonly known in industry as aggregate join indexes. So if you run Teradata and you run aggregate join indexes, that is the entity that I'm talking about right now. And there is some overlap in these capabilities, but there's also a little bit of difference. Views are wonderful for abstracting complex logic. Right? Instead of saying to your end user, hey, go join these 17 tables and that's the answer to your problem, you can write a view which will actually return the right result, and you can just give them the view and say, select star off this thing. That's how these things are often used. Both of these capabilities enable that. The difference with respect to explicit reference, and this is work that we've done in the query optimizer of Synapse, is where to reference a regular view, I name it in my query. But the beautiful thing about materialized views, which is unique in cloud warehouses today, is that if you go and reference or write a query against 2 or 3 tables or 5 tables or what have you, and we can resolve that far more effectively because we've already materialized the result sets, the optimizer will automatically match that. So if you think about the theme here of trying to take the responsibility away from the user, we're not asking users to understand security and they can only access this view for security. That's not scalable. So we build row level and column level security into the platform. We're not asking them to know that you need to query this materialized view to make a query go faster than querying that one, for example. We build that all into the optimizer. All we ask the users to understand is they've got a bunch of tables, they can write queries against them, and at runtime, the QO will look to see if there are optimizations, and it can rewrite that query, which is basically the job of the optimizer, obviously. The other interesting thing here is we've built some syntax that will let you generate recommendations of what to materialize. So if you have a workload, you can generate an execution plan with a recommendation syntax, and it will actually guide you on the materialized view to create, which will be most optimized for solving a given query. And so as you start to profile these workloads, and you can see where there are really long-running queries, rather than grab the query and have to eyeball it and figure out what's happening, you can just ask for a recommendation, and we'll tell you what view to create. Go create it, and you should see those query times plummet. And so I think I touched there a little bit on performance as well. The view itself is just an abstraction, whereas the materialized view is actually leveraging pre-computed result sets. Materialized views, the tax is you do require additional storage. The good news is you're storing it on cloud storage, which is pretty much the most economical storage on the planet. And so if you want to throw down a few extra terabytes of materialized views to save you from probably larger compute cost, that is probably a suitable trade-off to make. And you might find that this actually pushes your cost down even further relative to some of these legacy platforms you're migrating off. Both of the objects are completely securable, so I can grant, revoke permission, all of those kind of things. And then with respect to SQL support, because we materialize results and we maintain delta changes to materialized views, they don't have full SQL fidelity. You can't just write a whole query. But with views, obviously, you can. You can do anything you want, really. Materialized views, the intent really is to aggregate and join. I mean, maybe that's why some people call them aggregate join indexes. And then let more complex queries leverage them where they can. And so just a couple of quick code examples here. You can see here, for example, this is a basic view. I'm using some window aggregates here. I've got rank, I've got sum, order by, etc. You can't build this in a materialized view. We can't manage this. But with a materialized view, what it looks more like is I'm going to take some tables. One's got 65 million records, one's got 1,500, and one's got 26 billion records. And this is going to be a really expensive join, because I'm joining between 25 million records and 65 billion records. I don't want to do that over and over and over again for possibly the exact same query. And so I can materialize that into a view, which is what this does here. You can see the aggregate and the group by. And what that becomes, and the join, I should say, and what that becomes then is a materialized view with only 287 million records. But now when I bring queries that can leverage that view, the QO will automatically reference it. So now I want to show you what that looks like very, very quickly. Okay, so let's flip over to here. So here I've got a view. I can go and create this, and you'll see this is going to actually create very, very quickly. This is a regular view. This materialized view takes longer to build, obviously, because I've got to compute the whole thing, run all these joins. I'm not going to run it right now. But what I want to show you actually is I have this view called Materialized View Store Sales Summary, and it's comprised of store sales to customer and store. Now I'm going to come and run a query. I'm actually going to do an execution plan to say, hey, give me the sum of these joined tables. So let's go look at that. Oops. Where are we? Now, I forgot to install Zoom it before the session, so my apologies. But what you'll see in the very bottom right corner in tiny text on a yellow box is that we're actually referencing Materialized View Store Sales Summary. My query didn't explicitly reference that view at all. But when I came to run my query, the optimizer said, no, I can do better than this. I'm not going to do this crazy join that's going to take 15 minutes to run because it's huge. Let me go to that pre-computed result, and it's going to come back in a matter of seconds. This is the power of materialized views in the platform. I can do one more example quickly and say, I'm going to do something completely different. I'm going to do a count distinct. There's no count distinct in here. But because I'm actually hashing on this, the optimizer understands how to optimize count distinct scenarios. And so 3 tables, oops, this one here, 3 tables, count distinct, not referenced. Let's go run this guy. And I get the same result, materialized view reference. And so these are really, really powerful. They make no assumption that the user is going to write a specific query or what have you. The optimizer, if it can do it, it will leverage it. And if it can't, it just runs it across the tables and it all just works. Okay? So these are some of the really advanced features in Azure Synapse that enable you to run these very, very large workloads. And like Rohan talked about this morning, the petabyte class that we've done. Now we're coming up on time, so I'm going to need to accelerate dramatically here. These 45-minute sessions are tough. A couple of other things that we've done, and I might just skip this demo to move through it quickly. Actually, this one. One of the problems that we had, and I don't often put error messages in slides. That's not common practice. But one of the problems that we've had historically is you could not update the hash distribution key. This was annoying, right? You want to update any value in the table. Another problem that we had is you couldn't put joins into update statements. This was annoying. Other platforms supported this, and you needed to basically create temporary tables and then join against them. So the good news is we've solved for both of these as well. Again, these, like multi-column distribution, will be coming sooner, but these were other headaches in code conversion that we were asking customers to recode workarounds for, and streamlining these two has also proven to be a dramatic time saver. What I'm going to do now, actually, in the interest of time, is invite Ann Cruz to come up, please, and talk a little bit about Walgreens' experience with their migration to data warehouse.
Thanks, Charles. So you showed us really, really cool stuff that puts us into the exciting world of data science. I'm sure all you guys came here to actually hear about migration efforts. Everything that Charles talked to us about is something, hopefully, that interests you guys on how supposedly make it quick, but you told them it's really hard. And you talked about time, cost, and risk. I'm going to flash through my presentation so that we can come up with time. So my name is Ann Cruz, and I work for Walgreens. I'm an IT manager supporting the supply chain operations of our retail industry here in the US. My business users has an application called Merchandising Portal, which is hosted in a Netezza appliance. That application processes about 17 billion records daily, and when you are working on supply chain analytics, the minimum amount of data that you actually want to do a comparison of is about 2 years worth of data, so you can always do last year versus this year. We're talking about on-hand, sales, and all that so that you can have basically data-driven decision for your operations. So why did we migrate? And again, I wanted to highlight that Charles talked about migration is not easy because of 3 factors: time, cost, and risk. Time, I don't have time. Cost is okay because it's necessary. Risk, there's always a lot of risk. So what was my use case? All the technology that we talk about here in the conference is really good. But for me, it's only valuable if it actually converts into a business value proposition for my business users and for our customers. My use case is I have 2 major problems. One is when we acquired Rite Aid last year, it means we're going to have more data coming in. Second, I am in a Netezza box. And if you guys are in Netezza, you probably have heard their end-of-life announcement for the Netezza and the Striper model. And it happens all the time, right? 5 years, 6 years, hey, you're end of life, you have to get to the new one. It's just tiring. So I looked at other options out there, and this is where I came up with, let's migrate to the cloud. The other option, we looked at our other cloud solutions, but we actually ended up with Azure SQL Data Warehouse. And apparently, as of this morning, I'm already a Synapse customer. Early adoption without an effort. That's how easy it is. I can just claim it. Our Netezza appliances are an end of life as well, and it's at capacity. This was our old architecture. It's not current. These are like slides way back in early this year. So as you see on the left side of the screen, we have all of our data sources that we feed into our Netezza box. Ranges from our financial database, store inventory, item master data, and then we feed it into our Netezza box called NCDBA, and that's where we do all of our batch processing. And then we have the Netezza app, as you see below, where it is fully dedicated into hosting our web application so that we can ensure high availability. So what did we do? We took out all of the Netezza, and we moved all of our files into Azure Blob Storage. And then we use another ETL job to actually load it into our Azure SQL Data Warehouse. And Charles, you said time. It took us 3 months to actually migrate about 100 terabytes of data into Azure SQL Data Warehouse. So I'm not sure if that's actually a constraint, but I think it's really, really fast. So what are the benefits of moving into the Netezza? In terms of moving from Netezza into Azure SQL Data Warehouse, in terms of savings, being in an appliance, you have to actually pay 20% maintenance cost and the overhead of having people maintaining this system in your data center. In addition, you're paying that storage and compute whether you're using it or not. When you're in the cloud, you only pay for what you're using. In terms of productivity, when we were at Netezza, every time we're running our batch processes, I have to limit my business users and not let them run any ad hoc query. Or if it's running longer than 5 minutes, I have to kill it, because otherwise, we will not be able to meet our SLA. That's no longer a problem, so that does not impact productivity of the business. In terms of performance, it's not limiting anymore. We can scale up, we can scale down, depending on what we need. Based on the previous months, we are actually hitting our SLA way earlier, because if there's any delay in the data that is coming from other source system, we just scale the DWU, and we can always make up the time for other systems that are sending us delayed data. And of course, there's the disaster recovery. If you are on Netezza, you're not actually going to buy a lot of Netezza boxes just for your development, test, and for your disaster recovery. So with the cloud option, all those are possible. And The disaster recovery will take minutes. And if you guys are interested in more details and to see code of that, attend my session tomorrow, 3 o'clock at the theater for Microsoft Mechanics. I'm going to skip the lessons learned and just tell you guys, when should you consider cloud migration? Cost effectiveness. I don't think it's a one solution, right? The cost effectiveness can actually, depending on your use case and where you're coming from. For me, it's actually a third of the cost compared to buying another Netezza. Quick and easy setup, Netezza and Azure SQL Data Warehouse is largely the same. So the adaptability from my team on using it is just seamless. I didn't have to send them into training. And then you don't have the maintenance fee. You'll have the scalability, agility, and flexibility that cloud has to offer. And that's all I want to share. Thanks, Charles.
Thank you. Thanks, Anne. Appreciate it.
Thank you.
So we're coming up hard on time here. I did have a couple more demos that I just want to show you really, really quickly. So I'm just going to switch over to those very, very quickly here. So the first thing I talked about was code conversion, right? What do you do when you've got 100,000 tables, 200,000 views, astronomical amounts of code you want to convert? Well, as I mentioned, we build a tool. And so this actually has 88 tables only, right? It's not really big. But this is what it looks like today. I can go run this, and in about 2.1 seconds, I've converted 88 tables from Teradata to Azure Synapse. Now, what do you do then if you've got these 88 tables, right? Like I mentioned, we will make this available to you. You'll be able to download this. You'll be able to run this. You will be able to bring that full automation of migration of code directly to your ecosystem. You can work with Microsoft if you'd like to partner with. That's how we've been doing it with customers so far. But we will provide fully, very, very robust tooling that have been built for quite a while now to accelerate this code migration. But what do you do with that code once you're ready to start then iterating more and building and deploy it? Well, the other thing that we've done is built SQL data tools for Azure Synapse. And so if you've built with SQL Server data tools for SQL Server for probably the past decade or so, and you enjoy things like database projects, version control, continuous integration and continuous deployment, unit tests that are written in SQL, they are now fully available for Azure Synapse as well. And so imagine that I've actually gone and converted my code. I've got a dev instance which I've just stood up and deployed all that code to. Now I want to bring that into version control. So what I can do here is I'm going to just click on my project and say, I want to import a database. I'm going to select a connection. And this is actually one that I ran some of these demos of today. Imagine this is where I've just deployed all of that fresh code that I've converted. I'm going to click connect. This is all I need to do. And I'm going to hit start. And so this is going to line up. It reads all of the catalogs and schemas within my Azure SQL Data Warehouse. It's going to pull all of these down into my browser. Sorry, not browser, into Visual Studio. And what you'll see here is it's going to populate in the Solution Explorer. And now I have a solution in Visual Studio that contains all of my database objects. I can go and check that into Azure DevOps. I can start to write unit tests. Every time I deploy it, I'm going to rerun my integration tests. And this is super, super important, particularly for data warehousing, because now I can have teams of developers that are onshore, offshore, home office, interstate, where have you, all working on a single data warehouse code base. And when I deploy that, it's going to run through all of my tests and check I don't break anything. And that's important because if you centralize all of this data, you have this hyperscalable system where hundreds or thousands of people are using it, and some rogue developer breaks something, the impact is pretty far-reaching. And so now bringing the full robustness of application lifecycle management to building your data warehouse, you protect against these things. It's not radical doing ALM. We do it for .NET. We've done it for SQL for a long time. But now you can do it for your cloud data warehouse as well. So that was everything that I had with respect to the migration session today. Let me just switch back to here. The final thing I'll just call out from a partner ecosystem is on the reverse end as well. We talked about the data integrators. If you're running some of these visualization tools as well, and Datometry is a company we partner with for virtualization, you can actually put Datometry between reports that were written for Teradata and Azure Synapse, and it will translate that code on the fly. So what I just showed you is converting schemas and changing the platform, But if you don't want to go and refactor all of your reports, maybe hundreds or thousands of reports, Datometry is something that can sit in the middle and do that translation for you. And so we have a very rich ecosystem on both ends of the solution for Synapse, both integration and reporting. These all continue to work, and you're not going to find any problem with moving to those. And so with that, I will just start to wrap up. We've got a couple of final slides. Evaluations are always important. I love evaluations. Please, comments as well. Obviously, you would imagine as we start to move into Azure Synapse, we're starting to deliver some new content as well. We're not recycling. So feedback is very much appreciated there. And then obviously this as well. So with that, I'll wrap up. We've got tons of other resources that are available through the conference. And I can take any Q&A, or I'll hang around at the end and take some questions at the stage. So thank you, everybody.